All right. So, what happened, Arab? Okay, in this class, I'm going to ban emojis, unnecessary texting. Okay, those are strictly prohibited. Hi, Ritika. So, playing with emojis, texting, creating anything which is distracting everybody in the class is strictly prohibited. Okay, I cannot say it louder than that, and I would assume everybody understands English better than me. So please don't make me repeat myself. All right. So what we are going to cover today, I sent a message with the topics for today, and geometry remains a consistent topic towards the last 15-20 minutes of the class. So apart from that, we are going to talk about equivalent expressions, and then one variable equation and one variable inequality. Okay. So now let's start with equivalent expressions. What do we mean? Expressions. What do we mean by expressions? Not Arab. Let's wait for anybody else. I'll tell you why I'm stopping you, Arab. Okay, Nihan, go ahead.
An equation, or like an equation with no equal sign.
Okay, that is one definition. Now let's come to Arab. Yes, Arab. Give me a
Yeah, it's like an expression like to solve something.
Okay. Expression is to solve something. I will put it a little differently. See, when I say expression, let's say I come to the class every day and I just keep on smiling. I keep on showing expressions. Okay, sad expression, smiley, depressed, surprised. Hitesh. Yeah. Once I see them, I'll let you go. So, expressions doesn't mean anything. Sit down. So, expressions don't have any outcome. That's what I mean by that. Okay. So when you have, like what Arab explained, that if you have an equal to sign, that is when it is an equation. If you don't have an equal to, that is expression, meaning there is no outcome. Yeah, Gitesh.
The board is a little like the screen is like.
I cannot change the board right now. I will keep on reading it for you if there is something that is not clearly visible. Okay. I hope everybody else can see the board, or you guys cannot. Okay. Okay. Now, so when we talk about, let's look at this. 4x plus 3y and 4x plus 3y equal to 17. This is a classic example demonstrating the difference. You have an expression, no outcome, just my smile. I keep on smiling the entire class without doing anything. That is expression. When I teach you guys something in the class and there is an outcome, that is equation. Or when you have an equal to sign, that is an equation. Yeah, I know it's a very very raw definition of, or raw way to differentiate expression and equation, but I hope that gets registered. Now if you have an equal to sign, you have an equation. If you don't have one, then we are talking about expression, meaning my smile without a reason. Yeah. Here, Rehan. All right. Is everybody with me so far? Now we are talking about equivalent expressions. Now, if this is my expression, it doesn't have an equal to sign. What do I mean by equivalent expression? Any? Yeah, Dikshita.
Something that is equal to the expression.
Okay, that is equivalent. Okay, let's see what Sanvita has to say. Yep.
An expression that has the same value as another expression.
Okay. Somewhat relatable. Let's see what Advik has to say.
Like Sanvita said the same thing, but like in a different form from the expression.
Okay, another form which has similar value. So Arihan, you have joined just now. Today we are going to talk about equivalent expressions, and then we'll talk about single variable equation and inequalities. Okay, so we have started with the equivalent expression. So let's see what Arav has to say, and then we'll resume. Yep. One-liner expression.
Can you repeat the question you just said again?
Then leave it. I have heard some answers, and now anyways I'm going to explain it, so that's fine. So when I say what is equivalent expression, this is my expression, and one thing that we need to remember is I can literally play with this. I can multiply with 3, I can multiply with 5, I can multiply with 2 million also. I can divide by 50, I can divide by 2 billion also, and doesn't change. Meaning the overall behavior of the expression doesn't change. The overall outcome that we'll get by converting this into equation doesn't change. So be it an expression or be it an equation, same way if I have 4x plus 3y equal to 18, if I multiply this by 5, this is still the same equation. Or for lack of a better way of expressing it, we can say this is equivalent equation. If I divide everything by 10 also, the whole equation or the expression, this is called equivalent of this expression or equivalent of this equation. So in one line I can say, if you have an equation or expression, you can divide or multiply that by a common number and it doesn't do any harm. It doesn't change the behavior, it doesn't change the outcome, it doesn't get you a different solution altogether. Does it make sense? Okay. Ritika, Vian. We have Vian also in the class. Hey Vian, how are you?
I'm good.
You're good. This is your first class, and I know you were supposed to join the last class and you were not well. So welcome to the class. So for kids who are joining for the first time, I mean it's only Vian today. But what we do is we focus on learning the concepts. I will probably give you some examples which is more relatable in real life, and then we try doing some problems, and whatever we learn in the class that gets recorded. So my request to everybody in the class would be, don't be busy taking notes, because everything that we are doing in the class, that is recorded. You guys are not recorded, only me and the board, and I put that on YouTube for you guys to use that for revision or whatnot. Okay, but so you can utilize the time, and then after the class I give a little bit of assignment which I request you guys to do it, and whatever assignment I give, that will not take you more than 30 minutes in a week's time, altogether 30 to 45 minutes maximum. But that just affirms that whatever we are learning, we are able to apply those concepts for doing the problems. Okay. Alright, so now coming back to the equivalent expression or equation. So I said that whatever equation or expression I have, I can multiply or divide that by any number without being hurt, without being concerned, without being worried about it. Yep. So if I have, let's say, an expression like 2x minus y plus 5x squared. Let's say this is my expression. So this expression is same as I can do this and I don't have to be worried. My answers, my value, my overall outcome from this expression is not going to change. I can safely do this. If I have an equation like 5x minus 2y equal to 7, I can safely, yep, okay, you can. Alright, you can safely divide this by 1 by 3. What do I mean by that is, divide this by 3, divide this by 3, and divide this by 3. And you are still safe. Nothing is going to change. Your overall outcome from this equation or the value or the solution that you will get, that will not change either. Just give me 10 seconds, I'll close the door. So that is the most important thing that we need to keep in mind. That when you have an equation or expression, you can multiply or divide that by any number. I mean, it should be, the only word of caution I would say is don't multiply this part by 5. Let's say multiply this part by 5 and multiply this part by 3. This is not a mistake. This is a crime. Okay? When you are multiplying, you multiply the entire equation or entire expression by one number. When you are dividing an expression or an equation, you will multiply everything by one number or divide everything by one number. You will not toy around with the numbers and use it differently. Is that part clear to everybody? Gitesh, clear?
Yeah.
Myra, clear? Ritika?
Yeah.
Dikshita?
Yes, sir.
Okay, alright. So, now I'll give you guys a quick check. I have 3 by 5x plus 2y. Give me 3 equivalent expression for this one. Give me 3. Yadav.
2 by y plus 3 by 5x.
No, don't rush. No. Wait. I don't appreciate when kids do things in a rush. My question was, did you hear me completely?
Yeah.
I said, no, don't answer quickly, beta. Just hear me completely. I said 3 by 5x plus 2y is my expression. I want you guys to give me 3 equivalent expression. I'm talking about 3 equivalent expression. And I would want you to do it, write it in a piece of paper and then read it from there. Right after completing my question, if you're answering me, I can be 100% sure that you're going to make mistake. Because that certainly goes against the basic principle that I would not allow you guys to go against. Yeah, Advik.
Are you good fractions like 3 over 5 or 7 over 9 and that stuff?
I mean, you can choose. I will just let you decide. You can multiply it with a number, you can multiply everything with a fraction, up to you. What I'm saying is, whatever multiplication you are doing, you'll do it with all the terms same way. You'll not differentiate. That's all. Okay? So I need 3 equivalent expressions for this one. Yes, Arihan.
I have an answer.
Okay? What are those?
Like 3.
What 3?
3 outside of the brackets.
Okay.
Yeah.
So that means you also missed part of my question. I said I want 3 equivalent expressions, meaning one would be this when you are multiplying everything by 3. Other one could be when you are multiplying this by maybe 20. Third one could be when you are dividing this whole thing by 5. So I said 3 equivalent expressions. That's what you'll deal with. Yadvik.
I'm done.
Yeah. So again, this was no brainer. This was an easy one. I was just trying to get you guys used to what you mean by equivalent expression. Okay. All right. So this expression is same as this one. Is same as this one. Okay. Yeah, Gitesh.
One of them I wrote 6 outside of the bracket, one of them I wrote 5 outside of the bracket, and then one of them I wrote 9 outside.
Same. Yeah. And see, I was generous enough to ask you guys to give me only 3 expressions, 3 equivalent expressions. You can do 1 million also if you have enough time. You guys have holiday today or tomorrow also, right? You can use that time for writing 2000 equivalent expressions for this one. I'm just kidding. Okay. Now, Vian, is that clear to you, beta?
Yes.
How about you, Ritika?
Yeah, it's clear.
Okay. Now, let me tweak things a little bit. I have 5x minus 20 equal to 15. Find out the value of x. 5x minus 20 equal to 15. Find out the value of x. Yes, Ritika.
Should I say the value?
Yes, please.
X is 7.
X is 7. Okay. Okay. So I know you did it right, but I have a surprise element for everybody. Let's see what Sanvita has to say. Yes, Sanvita.
I also got the x is 7.
Okay. Now let's see if Arihan has to explain this to me like a baby. Okay. I am a baby. I don't know how to do it. How do you explain that to me, Arihan?
Wait, can I first say my answer?
Yes, sure.
My answer is x equals -1.
X is -1. Okay.
And wait, never mind. I think I did something wrong.
Okay. Okay. I will give that opportunity to Advik. Advik, I'm a baby. You have to explain this to me.
So the answer I got was 7 because like when we see the equation, we can move the 20 on the other side, but we must change the sign because it crosses the equal sign. And then we would have 5x equals to 20 plus 15. 20 plus 15 would be 35. And so if we move the 5 on the other side, it would be multiplication. No, it would be division, not multiplication. And so 35 divided by 5 equals 7. So that's how I got x equals 7.
And do you think a baby would understand all that?
No.
Okay. Alright. So now let's come to, see, I know you guys know how to solve an equation. I have zero doubt about it. What I was trying to show you guys here is, this is a classic example of an equivalent equation that you can, that concept also you can apply here. Now, I mean, whatever you guys did, that is perfectly fine. There is nothing wrong with that. But I'm just trying to apply another concept of equivalent equation here. Now, what do you see here? I said, when you have an equation, you can multiply or divide that by a number. Here, if I look at it, I have 5x, so 5 is here. I have 20, which is again a multiple of 5, and I have 15, which is again a multiple of 5. So I can safely divide it by 5 and whole thing doesn't change for me. So remember, you guys got x equal to 7, and I'm going to show that to you by applying the equivalent equation concepts. So here I have 5 common in all of them. So what I'll do is, I'll divide everything by 5. So whatever equation I had, I'll divide this by 5. What does it mean? I'm dividing this by 5. So 5x by 5 minus 20 by 5 equal to 15 by 5. Tic tac toe, gone. This is 5. So 20 becomes 5 into 4. Tic tac toe, only 4. This becomes 5 into 3. Tic tac toe, 3. So x minus 4 equal to 3, or x equals 3 plus 4, 7. See, our answer matched. So when I was saying that, if you have an equation, if you divide or multiply that by a number, your overall equation or your solution doesn't change. And that's what we saw it happening just now. Yeah? Did you guys have enough evidence to agree to what I was saying before with respect to equivalent equation or equivalent expression? Yeah? Is it making sense? Arihan, Vihan, Sanvita, Deekshita, Myra, Ritika, everybody?
Yes,
Okay.
yes.
Yep, Vasundhara, yep. So Vasundhara joined very quietly. I did not even notice when Vasundhara joined. But Vasundhara, are you with me, beta? Yeah? Yes, Vasundhara. Go ahead. Unmute yourself. Okay, yeah. No, I was just making sure that when you guys join, right, I have to make sure that I'm not teaching myself, I'm reaching everybody. See, this is rhyming, teaching and reaching. Alright. So, one thing that we can blindly assume here after that, if I have any equation or expression, I can divide it by a number, multiply it by a number, as long as I'm doing it diligently without messing around much. I'm not going to change the overall behavior or outcome from the expression or the equation. Let's say if I have 5x minus 6 equal to 18, even if I divide everything by 5, it'll be fine. You don't have to worry. Even if I divide this by 6, there's nothing to worry about. Even if I divide this by 5 million, because I love complex problems, still okay. Yeah? Don't divide this by a. I mean, you can divide this by a, but this will remain like alphanumeric thing. You already had one variable, one unknown, now you have two unknowns. So, I mean, you can divide this by a also. It doesn't do any damage. But this is what do we mean by equivalent equation or expressions. Is everybody clear? Now the next one is called, next topic that we had for today was dealing with, let me read it for you guys. One variable equation and one variable inequality. Meaning an equation with one variable. If I am talking about 4x plus 3y plus 7z equal to 18. I am actually talking about an equation which has three variables, 1, 2 and 3. If I ask you guys, okay, you have an equation, solve it for x, y and z. No matter whether you want to sacrifice one of your holidays or whether you want to sacrifice 20 of your holidays, you will not be able to solve it for three variables with one equation. What you need is one for one, meaning if you have three variables, you need three equations. If you have two variables, you need two equations. If you have one variable, you will need one equation. If you look at this situation versus I say 5, why 5? This has become my favorite number today. So 21x minus 17 equal to 82. Look at this situation versus this situation. I am talking about this equation which has three variables, and I am talking about this equation which has only one variable. If I am being put on the spot for solving this one, I will be more than happy because I have one variable in the equation. I can easily solve this, right? Like the way you guys solved 5x minus 20 equal to 15. That was also a classic example of one equation with one variable. And this is the easiest form of an equation that we can deal with. If you have one equation with one variable, you can easily solve that, and that's fairly straightforward. Okay, from this you can always solve it. So we'll talk about equation with two variables. We'll talk about equation with three variables also, but in the subsequent classes. Okay, so we are going step by step, right? So what we are doing right now is we have picked up all the concepts from 6th to 8th grade and we are doing one by one. So we are dealing with one equation with one variable. Now, if I add a little bit of spice to it, okay? Let's say if I say 4x minus 20 equal to 16. This is my equation, one equation with one variable. How many answers I can get? How many answers I can get? Yeah, we won. So my question here is, if I have an equation here, how many values of x I can get? Any guesses, Dikshita? Yep. Yeah, go ahead, you're talking on mute. I cannot hear you.
I think it's only like 1x.
Only one answer. Yeah, you can get only one answer. Correct? If you have one equation with equal to, you will get only one answer. What will be the answer? Okay. So if I say 4x minus 20 equal to 16, so if I try solving it, I'm making this guy cross the border. So minus becomes plus, so 16 plus 20. So 4x equals 16 plus 20 is 36, or x becomes 36 divided by 4. This is how it comes, right, when you are doing division. So this comes here. So, and you got one answer, x equal to 9. That's a firm answer. You have no doubt about it. I'll sit down. Now, I don't get happy by making your life easier. I'm a person who loves bothering kids. Yeah? Do I? Now I'm saying, okay, now find out how many answers you can give me. Yes, Gitesh.
You know, like whenever you could like also start. Can you start with division instead of doing addition first? Like, why not?
What are you talking about?
Like in the equation, when you solve it, you can solve it like 20 plus to the other side, and then you can do 36, or you can divide 4 on one side and do that to the other.
That also you can do. So that's where we talked about the equivalent expression or equation, right? So as soon as you found that you have 4 being common, you can simply divide by 4, and then that becomes simpler, and then you can go about it. Okay? So that we already covered. So that is perfectly fine. There is nothing wrong with that. Now, right now we are talking about a situation where I don't have an equal to sign. When I have an equal to sign, we found the value of x that came to 9. So that was only one answer. I'm talking about a situation where I had a mischievous intent. So instead of equal to, I said no. How about this? Tell me how many answers you can get. Let's see what Vian has to say. Yeah, Vian.
So there are infinite answers. You can use anything above 36, 36.1, 37, 38, like that.
Yep. So I got you got the concept part of it. There's a minor tweak or correction I would do, but let me hear everybody else. Let's see what Arav has to say.
It can be infinite numbers of x because there is no limit to how great 4x minus 20 can be from 16.
Okay, okay. So you also got the concept. Let's see what Advik has to say.
So in this equation, we can get like anything above 9.
Yes. Anything above 9. Yes. Arihan, you have something else to say?
No, I can say something.
Okay. Yeah, Deekshita, same answer.
Are we getting only one? Why are we getting so many?
Yes. So, see, when you look at it this way, right? Now, I don't have an equal to sign here. I have a greater than sign. So, when I solve this, what will happen? Okay, now since Gitesh said that we can divide it. Okay, so I will divide everything by 4. Okay? And then look at simplifying it. So 4x by 4 minus 20 by 4 is greater than 16 by 4. Up to this much is okay? This is equivalent equation. Now, this 4 and this 4 I can knock off. Tic-tac-toe. This is 4 times 5, 20, and 4 times 4 is 16. So I got x minus 5 is greater than 4. Assume this like an equal to sign for now, okay? Just with respect to operation. So it becomes x is greater than, this minus 5 goes to other side and this becomes plus. So it becomes 4 plus 5, or x is greater than 9. Now what does it mean? Value of x is greater than 9. Now whether it's 9.1 or 99 or 2000 or 5 billion or 25 million, all holds true, because as long as the value of x is greater than 9, I'm okay. That's what this equation says. Yeah. So this is what is called inequality, where you are not dealing with equal to sign. You are not dealing with this situation. You are dealing with this. Or if you are dealing, even if you are dealing with less than 9, we are talking about infinite number of solutions. Anything and everything that satisfies this condition will hold true for this. So that's why this is, you have infinite number of solutions, and this is called inequality. Yeah. Alright. So we talked about equivalent expressions and equations. We talked about equations with single variables, and we also talked about inequality with single variables. There is no new concept. These are the things that we have learned in the previous classes also. We were just doing a recap, and we'll continue doing the recap, right? I mean, we have to revise the entire syllabus from 6th to 8th grade, which we'll do in the coming classes. So we'll stop here and go back to geometry, unless anybody has any question with respect to what we have learned so far. No questions? Shake it even more vigorously. Now, okay, all right. So let's go back to geometry. Everybody okay? Sanvita, Vasundhara, Vian, Tanu. Tanu has been very quiet today. What happened? All okay?
Yes, sir. All okay.
Okay, all right. So let's continue with some interesting concepts of geometry. So yesterday we were struggling with how to find out the formula for area of a right angle. Right angle triangle or right triangle, whatever you call it. But I'm feeling very cold here in the classroom. Let me just... Okay, now it's better. Okay, so a quick recap of what we did before, or what we know already. That we have learned before, or I kind of help you guys recall with respect to theorem of congruence. When you say two triangles are congruent, there are 4 theorems or 4 enablers that help you believe that. These are the 4 theorems. Okay? If I say two triangles are congruent, what I'm saying is these two triangles have everything matching. If I ever say that I and Advik are congruent, even my power of the glasses will match. Okay? Meaning each and every property is exactly the same. So when we talk with respect to triangle, every property, meaning every side will match, every angle will match. And you don't have to match all of them, even the area will be the same. You don't have to match all of them. These theorems tell you that. They tell you that, okay, if only 3 sides, meaning 3 sides of this triangle and 3 sides of this triangle are matching, this will be congruent. If 2 sides and the angle between them, meaning let's say this side is equal to this side is equal to this side, and the angle between them, these two are the same, then you can assume that these two are congruent. Third one is ASA, where 2 angles and the side between them. So if this angle and this angle is equal to this angle and this angle, and the side are matching, they'll be congruent. Meaning you can assume that everything else will match, even the area will match. And I'm just doing a recap, okay? So don't get tired. I mean, I'll be real quick. Now when you talk about RHS, this is a theorem that applies for right angle triangle. Meaning, if you have 2 right angle triangles, and when the hypotenuse matches, so hypotenuse of this one and this one matches, and one of the side, be it this side and this side matching, or this side and this side matching. So if you have 2 right angle triangles, only the hypotenuse and one side matches, you are good. You can say that these two are congruent, meaning the area of both the triangles will be the same, every other property will match. Now let's keep this information handy with us, and let's look at how do we find out the formula which says the area of a right angle triangle is half into base into height. That's what we are trying to derive, because as a teacher I never ever believe in giving you guys a formula, say okay, memorize this and use it. I will never do that. Okay? So this is my right angle triangle, this is my base, and this is my height. This is 90 degrees. Okay? And I am trying to find out what will be the area of this guy. Is that expectation clear to everybody? Are you all with me? I'll ask this question to Ritika and Vian more often, and also Arihan. I can see the moving head, that gives me confidence. Okay, alright. Now, what we'll do is, let me draw a dotted line parallel to this line. And then from here, draw another line parallel to this line. Now if I look at, if this was my right angle triangle ABC, when I extended these two lines, I got another point B. And if I look at it carefully, this became my rectangle. Yep. Now, if I have a rectangle, see, my objective is to find out the area of this triangle, okay? The shaded region. I said shaded, I did not say shady, okay? So don't get the word wrong. I'm saying area of the shaded region, okay? Was that a poor joke? Okay, alright, let's keep it aside. Coming back to this one. So we are trying to find out the area of this shaded region. Okay? Ritika, are you with me, beta? Yep? Okay. Alright. Now, there's one more thing that we saw yesterday. I'm just helping you guys recall. If I have parallel line, a pair of parallel lines, and the third line intersects, then this angle and this angle are called corresponding angle. So this angle and this angle are called corresponding angle, because if you look at this, both angles are above the parallel lines and on the same side of the intersecting line. So if this is 1, this is also 1. If this is 2, this will also be 2. This is also corresponding angle, because both are below this. And then if this is 3, then this will be 3. Both will be same, because they are also corresponding angles. Both are below the parallel line and on the left side of the intersecting line. Yeah? Similarly, if this is 4, this will be 4. So, from the parallel lines property, we were trying to recall yesterday that if you have a pair of parallel lines and the third line intersects, your corresponding angles are same. Okay? That's the thumb rule. Now, also there was another thing that I was trying to prove yesterday to you guys, and where we left it was that if I have parallel line, let's pick only one pair, this one and this is one. Corresponding angles are same. I'm saying that this angle is also same. Why? Does anybody recall? Yes. Let's see who has raised the hand, or who was trying to raise hand. See, you guys go muted when I want you to be more active. Okay? Yeah, Rihan, tell me.
They're the same because, hopefully I could annotate on this. There's a circle, kind of.
Look at this.
And that. Yeah.
This is called opposite angles. When you have two lines intersecting each other, this angle and this angle are opposite angles, and they are the same. And I remember yesterday in the class I had given you guys an assignment that just draw two lines and measure this angle and measure this angle, and you will find that this angle and this angle are same. These are called opposite angles. Okay? And opposite angles are always the same. It's the inclination between this line and this line that doesn't change when you go beyond the intersecting point also. Similarly, this angle and this angle will also be the same. They are also opposite angles. Look at this. Angle is nothing but the inclination between two lines. Whether you are looking at this or whether you are looking at this. If you are looking at this part of my hand, this angle and where you are seeing my jacket, these two angles are same actually. Because the inclination, the way they are leaning against each other is the same. An angle is nothing but the way two lines are leaning against each other, isn't it? Yeah? So these are called opposite angles, and you cannot disagree with this. They will be the same. Now look at it. Okay, let me give you guys another reason why I'm saying this angle and this angle will be same. Okay. Now look at this. Look at this line. Okay, let's say this is AB. Okay. If you look at this line, here to here will be how much? 180 degree. Yep. And if you look at this line, let me give this guy a name. This is 2 and this is 1. Okay. So 1 plus 2 is 180 degree. You guys agree? This is straight angle. Yep. Now look at this one. This is CD. Look at this line. This angle, let's say this is 3. So 2 and 3 together also will be 180 degree. Yeah? 2 and 3 will be 180 degree. This is a straight angle. Yep. So this poor guy is common between this 180 and this 180 also. Correct? So then only thing is, see, if you look at this angle here to here, this is 180 degree, which has this plus this. If you look at this one, this plus this is 180 degree. So this guy is common between both the combination of 180, isn't it? So if this is common in this 180 and this 180, the only contention point is these two. And if this is not changing, why would these two be different? Yeah? Vian, Ritika, Tanu, anybody. I want you guys to argue and challenge me actually. Myra? See, I am saying this. There are two lines. This angle plus this angle is 180 degree because this is a straight angle. And this angle plus this angle is also 180 degree because this is also a straight angle. So between this 180 and this 180, this part is common. So this guy and this guy have no choice but to be same. Yeah? Dikshita, did it ring the bell? I saw a very positive expression all of a sudden, so I thought, oh, I was able to explain. But I'm still not convinced. Anybody having a doubt? Okay, now let me use a more intuitive way of explaining this. Because pictures speak 10,000 better than words. This is A, this is B, this is C, and this is D. I'll make your life more colorful. Let me do that. So now, look at this. Here to here, this is my blue angle. Okay? And this is, here to here is my black angle. Okay? And then I have a green angle also. Yeah? Now, this blue and black is 180 degree, straight angle. And green and black is also 180 degree, straight angle. This poor black angle is common in both 180, right? Do we have a choice where green and blue cannot be the same?
No.
No? Agreed?
Yeah.
Yep. Pranav, I heard a loud yes, so that gives me confidence. Vian, was that clear to you, beta? Yep. Ritika, what? I mean, I'm just missing that right sentence. Were I able to explain that? Yep.
Yeah.
Okay, wonderful. So now you guys cannot deny. You guys said that I was able to explain. So now hereafter, every opposite angle will be same. If you have two lines intersecting each other, your opposite angles will be same, no matter what. This and this will be same. This and this will also be same. When you have two lines intersecting each other, the opposite angles will be same. That has become something written in stone now. Yep. Alright. So I need a sip of water for sure. So now we go back to this one. So there are two things, okay? Remember this. When I have a pair of parallel lines and when a third line intersects, then corresponding angles are same, and also the opposite internal angles are also same. Meaning I can say if this is 1, this will be 1, this is corresponding angle, and the opposite internal angle, meaning the angle and between the two parallel lines and on the opposite side of the intersecting line will also be the same, because this one and this one are opposite angles which are same, and the corresponding angles are same. So this one and this one will also be same. Make sense? Now come back to this triangle. I am saying that I had a right angle triangle. I extended this by drawing a parallel line to this one, and extended this by drawing parallel to this one, and they met at this point B, which forms a rectangle for me. And if you look at this, let me use the color coding to make life a little easier for you guys. So I have two triangles now. One is the blue triangle and one is the black one. And both are right angle triangle, because when this one parallel to this guy, it is meeting at 90 degree. So the blue one is a right angle triangle, the black one is a right angle triangle, and this together is forming the rectangle for me. Is this part okay?
Yeah.
Okay. Now I am saying this blue triangle and this red triangle are congruent, and you will see why. My obvious answer to that is because these two are right angle triangles, and right angle triangles, for them to be congruent, we use the theorem called RHS. Okay? Or we can use any other theorem. Let's say we use ASA. We can use that because RHS is specific to right angle triangle, but the other theorem that we know about, that is applicable for every type of triangle. Okay? So let me use ASA. That's also fine. Here, meaning two angles and the side between them. Meaning, if I have to prove that these two triangles are congruent, and let's say I take this side is common in both the triangles, so one side is matching. Now, this angle and this angle will be same. I am saying blue angles are same. Why? Because these are two parallel lines and this is an intersecting line. These are opposite internal angles. Yeah? Are you guys able to relate? Yeah?
Yeah.
Vian, Myra, Arav, everybody with me? Tanu, clear? So, here, since these two are parallel lines, because I made them parallel, this becomes my opposite internal angles, and they are matching. They will match. Similarly, if I look at this angle, what happened? If I look at the green angle, this one, and this one, the green angle, they will also be the same, because these are two my parallel lines, and this is an intersecting line, and these are opposite internal angles. So what I see here is, I have two angles matching, and the side between them being common. So I can apply ASA and say this triangle and this triangle are congruent. Yeah?
Yeah.
Yep. Okay. So now when I say that these two triangles are congruent, whatever I did for last 15 minutes, even if that sounds cryptic, you have the video of the class that you can watch and revise it. But optically also, if you see, this triangle looks half of the overall triangle, rectangle actually. So if you believe that these two are congruent, then this area is equal to this area, or I can say area of my triangle, of my right angle triangle, is half of whatever this total area is. And I know my total area of a rectangle is length times width, or here if I call this length as B or base and this width as height, this becomes half into base into height. Yeah? No? Yes. Okay. Alright. So this gives us the area of a right angle triangle, which is half into base into height. Okay. Now, this is not enough. Right angle triangle is just one baby in the ocean of triangles. There's so many triangles. I'm saying that, okay, don't worry. Now you know the formula for area of a right angle triangle, which is half into base into height. I'm being mean now. I'm saying that, okay, this is the formula for every triangle actually. If I have a triangle like this, I'm saying area of this triangle is also half into base into height. Let's say if you take this as a base, then what you'll do is you'll draw a perpendicular from here to here, okay, and half into this base into this height. If you take this as a base, what you'll do is you'll draw a perpendicular from here to here, measure this height, this base into this height. I'm saying this is the generic formula. You will say what? And that is where that increases work for me. So let's do it now. Are you guys with me so far?
Yeah.
Hope nobody is getting tired of my dad jokes, right?
Yeah.
Yeah? Getting tired? Okay.
Yeah.
Okay. What to do? A dad of my age cannot avoid dad jokes, okay? Then, now, I have a triangle like this. Okay? I'm trying to find out area of this. What I will do is, I will try to convert this into a right angle triangle. Okay. Now, what did I do? I've drawn so this was my triangle ABC, and I'm saying my area of this is half into base into height, but we know that area of a right angle triangle is half into base into height. So this triangle, what I'm doing is I'm converting this into a right angle triangle. Okay. So I have this triangle. What did I do? I just extended this in a perpendicular direction and made these 2 points meet. And from this, I found that this is my right angle triangle. I made this 90 degree. So this is ABC and this is, let's say, DBC. This is another triangle. Okay. So if I have to prove that this area, this right angle triangle's area is equal to this triangle's area, then I'll be good. Yeah? Or if you look at it carefully, between the old triangle ABC and then this new triangle, right angle triangle DBC, only difference is this part. Yeah? The black and blue part. If by hook or by crook, if I can prove that this area and this area are same, then you would be able to believe that this right angle triangle's area is equal to this triangle's area. Yeah?
Yeah.
Tired. Exhausted. Yeah? Yeah, Arihan.
Wait, can we go back to the top triangle? And you know how you made the scalene triangle?
Right, so, yeah.
Would that be the same area as the other one? Because they didn't really have the same height.
Right. So first of all, Arav and other kids who are busy doing text messages, promise yourself that you will not do it again, because if you keep on doing that, then whatever I am trying to explain, unfortunately I am explaining to myself only. Okay? Please don't do that. So, okay, I am not going to prove this theorem today, okay, because that might be an overkill and it will need some time, okay, because you have to visualize this and do it. Now, what I am trying to say is, if this is my triangle, okay, and I am trying to find out the area of this guy. This is my base and my height is this one. Okay? I am trying to say my area is half into base into height. But the problem is that we don't know. There is no way I can agree to this. So what I am saying is, we know that, okay, area of a right angle triangle, okay, I mean 90-degree triangle, the area is half into base into height. That we have seen, right? Now, I am trying to find out, why would I believe that this area is also half into base into height? I know base and this is height, and there is no correlation between these two. Yeah? So, I would be more convinced if I make this a right angle triangle and this is my base and this is my height. Let's say if I ask you guys that is area of ABC half into base into height, you will say don't know, we have not seen it yet. But if I say area of DBC is half into base into height, you will agree, right? Because that's what we have seen. Now between this triangle DBC and this triangle ABC, the only reason why I am not able to digest whether this area is same or not, because this has one piece which is not present in this ABC, okay, the black piece. And so is the case if you look at the triangle ABC alone, the blue piece is not in this right angle triangle. So these are the two disconnected elements. This triangle, the right angle triangle doesn't have the blue piece. The original triangle for which we are trying to find out the area ABC, it doesn't have the black piece. Make sense? If by any chance, if we are able to prove that this black piece and this blue piece have the same area, then this formula will hold true. Yeah? Are you guys agreeing to what I said? Yeah? So that is what we will try proving in the next class, so that you guys are able to agree to what I am forcing you guys to believe. Yeah? Okay? Vian, Vasundhara, Tanu, everybody with me?
Yes.
So right now we have just set the expectation for ourselves. What we are going to prove tomorrow, or not tomorrow, in the next class. That I have a triangle, I am trying to kind of create a right angle triangle out of it, and if we prove that these two difference that we have between the original triangle and the newly formed right angle triangle, if these two are same, then we are good. Then we can believe that this formula holds true. And knowing that sometimes it gets a little difficult for you guys to understand, let me also think about and see if I can prove this in a even easier way. Okay? So that is what I will do in next 7 days, and you guys will have to make sure that whatever assignment I send you guys, just do it. It should not take more than 30 minutes of your time, but my sincere request to you all would be, do that assignment diligently. Sometimes I give wrong assignments also, and there is a purpose to it. Meaning if I am giving something that you have not learned, and if you are attempting to do it, that is when you will come back to me saying, okay, no, this one is not taught, I have not understood it. So that also gives me a reality check to know whether you guys are actually attempting the problem or not. Okay? Assignment or not. So, but anyways, enjoy the rest of your evening. You have one more day to go. Enjoy it to the fullest, and then see you guys next Saturday. Yep. Any questions?